Welcome and hello. This is a video exercise in HEC HMS. And in this exercise, we're going to be dealing with importing and using Daymet precipitation data. All right, what I have on the screen here is the link in the description. It's the web page where we will be downloading the initial project files and following the steps. So go ahead and download the first link here. This is the project. Go ahead and give that a click. There's two other links right here. There's a sub-basin outline that we'll use for flipping, and then the Daymet files right here. I am not going to download these files because I want to go through those steps myself. All right, looks like our project has been downloaded. Here's the zip file. If I open that up, we have a HMS model tutorial, and then here are the files for the project. So I'm going to go up one level and then go ahead and drag that directory onto my directory of choice where I want to keep it. And I'll just close that and then delete the zip file. All right, first things first, let's go ahead and open up this project in HMS and just see what we have. So HMS, I'll go File, Open, and then click the Browse button. All right, here is the project, so I'll double click that, and then click on the .hms file here at the bottom, and then select, and Convert Project. All right, here is the project. Let me open up the basin model. It is Black Earth Creek tutorial. So this is our watershed right here with way too many layers on. Let me turn those off real quick. I'll go View, Map Layers, and then let me just toggle some of these off. Okay, that's cool. I'll leave the terrain data on and the reaches and the subbasins. So here we have our watershed. It looks like it flows in the westward direction with the outlet on the far west end. One thing I want to do for my preparation of importing the precipitation data is to get an outline or a shapefile of the watershed itself. So if you downloaded that shapefile for the basin outline, you won't have to do this step, but I'm going to do it anyway. So I'll go up to GIS and then Export Layers. And then, click Subbasins. And then next, I'm going to cruise to the desktop. I'll put it right there. Then the name will be Watershed Boundary. And then Finish. Okay. Just to keep all these files in the same spot, I'm going to create a directory in my desktop here and just move all the shape files into that directory to kind of keep them organized. Okay, it's not going to let me do that. I think I have to close HMS. Okay, try again. Okay, that worked. Okay, I got HMS up and loaded. We're ready to go. Back on the instructions, if we scroll down just a little bit, there's a bit of an introduction. It talks about downloading the Daymet data here from daymet.orni.gov/getdata. So I'm going to go ahead and open that website up in a new tab. And where I want to go is first click on this direct download. And then after that, I want to scroll down here to my daily precipitation data right here, daily surface weather data. So I'll click that link and then go ahead and scroll down a little bit more. And what we see here is a table of downloadable .nc files. These are netcdf file format. And what we see here it says there's 1,134 files. So we can see them all just by clicking all. All right. So what we see is we just click it and download it. This first batch of files is for Hawaii. And we can just scroll down and read the file name to see what it is. For instance, we have precipitation from 1988, precipitation from 1989. Again, this is all Hawaii on a daily time step. If I scroll down a little bit more, we have radiation, snow water equivalent, probably not a lot of snow in Hawaii. And then what's next? Temperature min, temperature max, and so on. Once we scroll down far enough, we get to the North America data, which is right here. Here's North America precipitation. So actually, the data is much larger too. You can just tell by the size of the file right here. The last Hawaii data set here is 21 megabytes, and then the first North America data set is 1.3 gigabytes. I'm going to scroll down to the 2018 precipitation data for North America, which is this link right here, and it is 3.9 gigabytes. So I would go ahead and click on that. I already did that in preparation for this video, though. It took about 10 minutes. So if you want, go ahead and click on that. Next, I'm going to bring up QGIS and then look at that data. Again, this is daily precipitation data. I'm going to go up to layers and then add layer. It's going to be a raster layer. Now I need to navigate to that .nc file that I just downloaded. I click this ellipse button to select the file. Okay, the file is selected and I'll click add. Now I need to select what parameter or variable, and I'm going to select this one here, precipitation, and then click add layers. Okay. that's been added. Here is North America right here. If I identify a single point, I will see the data pop up in the right panel here. This is the identify results panel. So whatever location I click on, say right there, it gives me the precipitation at that location in millimeters in the year 2018 for, I believe this is day 1, day 2, January 3rd, January 4th, and so on for the 365 days. All right, so that's the data that we just downloaded. This is the precipitation data that we're going to be working with. Next, what we need to do is go back to HMS, and to bring that data into our HMS project, we need to go up to File, Import, and then we're going to go Gridded Data, Importer tool. So next up, I'll click the file folder here, browse to the .nc file. This is all that North American precipitation data in the year 2018. Click Open. Okay. Click Next. Now we need to select the variable, which is precipitation right here. I'll just click arrow over to select it and then next. The next step here involves cropping and then projection. So what I want to do here is select that shape file that we saved to the desktop, which was the outline of our watershed. Now, typically we may want to actually include a larger buffer beyond the watershed, but for this exercise, I'm just going to go with that watershed outline. Okay, so desktop, here's the watershed boundary shapefile .shp, and then I'll click open. The projection we're going to be using here is SHG, so I'll click OK there. And then the cell size, this is going to be 2,000 meters. I'm using 2,000 meters here because we need to be consistent with the discretization of the subbasins themselves. So if I go back to our HMS map and I click on any of the subbasins, here in the component editor, we now see that we are using a structured discretization method. And if I click on discretization, we see that the cell size is 2,000 meters per cell side. Also, the instructions say the same thing right here, that we should be using a 2,000 meter cell size. All right, so let's go back to our importer tool. And what we have here is 2,000 meters. We will use bilinear for the resampling method, and then click Next. And our last step here is to specify the output DSS file. So I'll just click on, say, the desktop to keep it simple. I'll call it precipitation.dss, and then click Open. For the path name parts, I'm just going to type in SHG for part A. This is what we're instructed to do in the tutorial, Black River Creek, and then part F will be Daymet, our data source. Okay, and then I'll click Next. All right, so that DSS file finally loaded. In this exercise, we already have a meteorologic model and a simulation model that's already been built using the NCRFC data, which is NextRad data. Now we're going to run the same model, and the only thing that we're going to change is by using this different precipitation data, which is going to be our Daymet precipitation data, and we'll also call it the Daymet simulation. So what I need to do next is go up to the Components menu and click on Grid Data Manager. Now, the data type will be precipitation grid set, and as you see, we already have our precipitation grid set for the NextRad data set. I'm going to go ahead and click New, and then paste in a name, or you can type in a name for the Daymet precipitation data. And then for the description, I'll do that. Click Create, and then close that up. All right, down in the grid data directory of the Watershed Explorer, I'll go ahead and expand precipitation grid sets and click on Daymet. Now what we want to do is navigate to this particular precipitation.dss file. Before that, I want to move this DSS file into my project directory, which is right here. I'm going to put it inside data. It looks like there's already some data here, but that's fine. So this is going to be called precipitation.dss. Now down here in the components editor, I'll go ahead and select the file name for the DSS file. Okay, here's the project right here. Here's the data directory. And then here, right here, is the precipitation.dss file. I'll next click on this button here to assign the path, and I'll just select the first path and then set path name. The next step is to create a meteorologic model. So let's go to Components, Meteorologic Model Manager. See, we already have one here. We'll click New to create a new one. I'll call it 2018-08 Daymet and create. We can close that. Now we need to make some edits to that Met model before we run the simulation. So Daymet model, What I want to do here is click on the Basins tab and change this include subbasins for our basin from no to yes. And then after that, I'll click on the Met model again. Oops, right there. And the Meteorology model tab. I want to change the precipitation from the default to gridded precipitation. And then at the very bottom for replace missing, I want to change this to set to default. All right, we're almost done. The last thing we have to do is click on this gridded precipitation icon and then select the grid name to be our Daymet precipitation data. We're ready to create a simulation. So I'll go up to Compute, Simulation Run Manager. Again, we already have one simulation here saved. We're going to click New, create a new one. It will be named 2018 Daymet. Next will be our basin model, our one and only basin models right here. I'll click Next. Now this time we want to use the meteorologic model for Daymet, which is selected there. Next. And then finally the control specification. So the last 2 weeks of August in 2018. This is the same time range as the other simulation. And finish. Now we're ready to run the model. So I'll go ahead and select Daymet from the drop down here in the compute toolbar, and then click this button here to compute all. All right, that looks like it's done. Good things. And let's go ahead and run the NextRad model as well. That was also fast and successful. Let's go ahead and look at some results here. So if I just maybe look at the outlet, the sync element, I'll click on that and then right click, view results, and then graph. Now we have the NextRad simulation selected right here. It also says that right up here in the title. And what we see is that the storm on the August 20th and 21st generated a peak hydrograph flow rate of about 3,500 CFS. And then if I select the Daymet model and then look at the exact same graph by right click, view results, graph, what we see is something totally different. Yeah, sure, there's still a peak right here on the 21st. However, the peak flow rate is much smaller. It's not 3,500 anymore. It's barely 1,200. And that's in CFS. You're welcome to click around and look at any of the other results, but the conclusion that the tutorial provides us is that the Daymet data does not adequately capture the rainfall intensity that fell over this watershed during that August 20 to 21st storm event. And this is because of two things. One, the course resolution, which is 2 degrees or 222 square kilometers, as well as the large time step, which is 24 hours using that Daymet data. This watershed is relatively small, and during the summer, rainfall events are rather short and in a small area. So in conclusion, the Daymet data set lacked the necessary accuracy for this situation. Well, that's it for this exercise. We downloaded data from the Daymet data website, imported it into HMS using the importer tool, ran a simulation, and then compared it versus another simulation that used the NextRad data.